people of micro builds. So, I did like a demonstration with this NexiTube driver already. But that video was kind of short. I was in a crunch for time, so this time I'm gonna have to film the video again. But I'm going to do it myself this time. Jeffrey is back. So let's get started. Okay, so basically here's where everything starts. So down here amongst my many cords, this one follows all the way down here and into this socket. So it goes all the way up this cord and into this 12-volt power supply. So this 12-volt power supply is 12 volts at 5 amps. And 120 volts AC goes in. I don't have it grounded because it doesn't really need to be. And then 2 sets of 12 volts come out. Now one set, which are these thinner wires here, go to this little module here. And this steps it down to 9 volts for the Arduino board, which is responsible for both powering and running the relay stacks. So I put a switch between all that half of the shelf and the 12-volt supply. So the reason the shelf looks kind of like it's off is because the high voltage is still on. That's the part that the tube desperately needs to work at all. This is just to make it all automated. Technically, I could just manually touch the wires by hand or like flip some switches, but there's no fun in that. So what I did instead is I took a bunch of relays and I interfaced them with an Arduino. So this basically means that each relay, so it's going to start at this one down there, which is going to light up number 0, and then to 1, 2, 3, 4, 5, 6, 7, 8, and 9. So I'm using the normally open side, so when the Arduino says go high on the control pins, it's going to send a high signal to the relay, and that's going to turn on the number. Now, what I can do is I can turn the switch back on. The high voltage was never off. See, to prove this other switch here that's labeled HV is just for high voltage. So I can turn that off. The relays will keep going, but the tube will not be on because in the other case, the tube has high voltage, but there's nothing to switch it. So now that we've figured out a way to successfully make the switching happen, then this was after frying 2 different transistor banks and finally just deciding on relays. High voltage BJTs are very expensive and hard to find, so that didn't work. So what I ended up doing instead was just, relays. Because they're cheap, they're effective, and that whole set there cost me $10, which is ironic because there's also 10 relays. So that's like $1 a piece, which isn't horrible. I spent about, I'm really just going to give the price away on this. So that was like $170. I already gave that away, it's just 10. That was 13. That one was, that doesn't really have an official price. I got mine for $11, but there are people wanting 30, 24, 11, 9, 7, and the list goes on. The thing under there was also just $10. A lot of these things were $10, but collectively they make up about a $300 driver. Oh, my wallet was sore. So aside from the point, I know I get on these tangents a lot, but that's not the point. So, the video does a good job of capturing this, but it's very pale orange in the tube. Again, I'm colorblind, and I still don't know what this is kind of looking like to y'all, but to me, on video, it's like a yellowy white. It's like an off-white kind of color. And in person, it's like white with like a blue haze. It's like a dirty white. Anyway, I still think it's pretty. So there's a little blue indicator, just like on this one, except I don't have electrical tape on this. So I just flip it upside down. I'll fix it later. So all of these are going to this SMD little like pin header thing, and that holds the tube into its pedestal socket thing. The person I got this from, his name is Dalibor Farney. Yes, I drew a sign with a ballpoint pen because I didn't own a Sharpie at the time. I bought plenty now. But, at the time, I had a ballpoint pen, so I took advantage of it, and all the letters are crooked. But, you know what? It's harder than you think to find just his logo that isn't plastered on a tube. So, the high voltage is basically just, that middle wire there is a control, so positive and negative are always connected, but that middle pin has a switch going through it because that's the shutdown pin. If it's not grounded, then the high voltage never turns on. So I have a little switch for that. So that's nice. Now, something I didn't address in the last video. This is something very important. This is not a light bulb. There is no filaments in here, and it doesn't get warm. This doesn't even get remotely warm. There's no heat. This is what's called a cold cathode display. I'm sure there's initials for it, but nobody uses them. So, there's a bunch of other cold cathode tubes, and I'll get one in a second. Another instance of a cold cathode display are, for instance, this VFD tube. Just kidding, no it's not. If you look closer, it has heaters. That's just a joke. So anyway, that's not really another cold cathode tube. But, I'm just going to put that back in its little container that I've beautifully drilled holes in for some reason. I was trying to turn this into a project enclosure, but I couldn't get all the parts in there. So, back to this. Where's Jeffrey? Jeffrey? There you are. Okay, so, 12 volts from here goes through the switch into this module. The positive goes straight to the anode of the tube. Then from there, all the control wires off the Arduino go to the back of the board, so does the 5 volts. Everything's wired up in parallel except for controls. And all of the common sides are connected to ground, and all the parts that are actually going to ground the individual numbers of the tube go in this little pigtail underneath the tube to the header, which will inevitably accomplish this. Now, earlier I said this was a cold cathode display, which means there's no heat, and it doesn't have a filament. Despite its color, it looks like filaments, but they're not. Now, there is a tube with filaments. Tungsten filaments, and it is basically a light bulb, but it's segmented. It's called the Numitron. If I ever get my hands on those, I'll definitely make a video about it, because I personally think it's a very beautiful format of tube. Nixie is inevitably my favorite, though. So, this tube is about the size of a tin can, or to my fingers for reference, I have about medium-sized hands. Those other tubes over there get really warm. This is still just like room temperature. This is like in the summertime when like there's no air conditioning, you just lie down on the tile floor. That's kind of what this feels like. It's very cold. It doesn't make itself cold, it just never gets warm. It's like the temperature of glass in a normal average air conditioned room. So the base is metal. It's not electrically conducted. Now here's something neat. This is the best part about having a giant handmade Nixie tube. There's only so many ways you can make the envelope, which means you can see down inside where all the wires come into the tubes. This is not the actual shape of the tube. The actual glass tube on the bottom has like this like mountain kind of thing, and it's called the stem. It has like the stem down in there, and then all these little tungsten wires come running up the tubes and into the little plates. So, this uses something called glow discharge. So let me get my notebook and I'll explain that. Okay, so let me explain glow discharge. So say you have like the number 9. And then over here you have the little grid. And then it's going to have a pin, and that's going to have a pin, and that's going to have positive 170 volts. And this one's going to have just negative 170, or just ground. So we'll put that over there as ground. So what this basically means is the little neon molecules in the tube, the positive side, is going to sling itself towards the negative because it basically splits the neon in half. So then the positive side is going to go this way to the negative, and the negative side of whatever neon technology is always going to be the side that lights up. So for instance, if I have a neon bulb and it has 2 of those little electrodes in it, if I hook that one up to negative and that one up to positive, this one's going to be the one that glows. So in the same sense, if this one's negative, then this one's going to be the one that's going to glow, while the grid is going to stay unilluminated. Now, if I switch this, so if I just draw a little arrow like that, then the grid's going to light up, which, by the way, is very unhealthy for the tube. Don't ever do that. The numbers are always supposed to be the stuff that's supposed to light up. So if that's not the case and this is trying to light up, then you have a very big problem. For instance, in my clock, so I had a little clock and it had like 4 tubes in it. And they're the rectangle kind, but I'm in a crunch for time because my phone's dying. Those are all going to, like, those tubes in there, I put them upside down at first. So the number 5 was acting like the grid over here. So number 5 was acting like a grid, and then in number 5's place, then the grid was lighting up. And I'm like, oh shoot, something's definitely not right here. And it wasn't. The tubes needed to be like the right way around. And then 5 would illuminate properly. So anyway, I'll get better at drawing, but as for now, my drawings are gonna look like this. So anyway, this is glow discharge. And here it is in action. So you can't actually see it happening, but from the side here, you can see that the glow discharge likes to occur about 1 millimeter around the actual wire itself, but it makes this beautiful orange color. Now, I have some neon bulbs, but I don't really have a way to connect it to 170 right now, so that'll be a later video. I'll discuss neon bulbs. They're very basic. It's like a Nixie tube, but there's only one number, which is none. It's a pole. Yep, so if I can find Jeffrey again. Why do I keep losing him? Okay, there we go. So it goes from the 12 volts through the switch into this, which is common negative. Yes, common negative, and then all the little control wires that can individually ground the numbers are going underneath the pedestal. Now the positive is basically just going to go straight to the anode. The Arduino is controlling the relays to switch all of this, and is also giving 5 volts, which is wired to all these relays in parallel. Now, in hindsight, this is a very basic concept. Building this thing took 4 months because it wasn't so easy at first. Also, if you shine a light on the tube, this is basically what the images on Google are going to make you think this tube looks like. Or if I get it even closer, it's going to appear like that orangey color, and it's like, this is what the people on Google was like, they're not paying attention to how their pictures are actually looking, and their tubes end up looking like this. But they actually look like this. I mean, it would be really nice if they look like that, but yeah, that's not how neon technology works. Now, Dalibor Farney, I was on his website, and he's actually, I don't know if he's developing or not, or just experimenting with the gas mixture, but he managed to make a blue Nixie by increasing the argon content in the mix of argon and neon, and it made a, like, magenta kind of tube, and to be honest, I would have much preferred to buy that, because those are rare enough as it is. Chances are that would have been much more expensive, or less expensive, I don't know. Anyway, it depends on which gas is more expensive and if Dalibor Farney decides that he wants to go through the extra work. He's really busy, so I don't think so. But anyway, it's fun that he managed to make a blue tube, because that's just incredibly entertaining. Now, there's about 10 other Nixie technologies I can name right off the top of my head. For example, Panoplex, neon bulbs, Nixie tubes, the Decatron tube, which is a kind of Nixie. There's the Burroughs tube, which is a segmented Nixie. There's the I don't know the name, but there's actually a segmented display from the 20s that uses neon bulbs, or not the 20s. That was those tubes. There was a tube from the 50s, like a 7-segment display that used neon bulbs instead of LEDs, and the modern day light pipe design, except it was much bigger to accommodate those bulbs, and they were kind of beautiful, to be honest. So, that tube I showed you, and I was like, cold cathode display when there's literally heaters in it. Just a practical joke. It's not actually a cold cathode display. That's what you call a heated cathode display, because it has heaters. That, out of anything else, is a heated cathode display. Because, like, when those heaters are on, you touch the side of the tube and it tries to burn you. I mean, it gets hot. It's like a light bulb that's been in the socket for a few minutes, just kind of running. So anyway, I'm going to end the video here. I really hope you enjoyed the more detailed version of the Nixie driver demonstration and explanation. Now you know what the doorbell wire's for. I don't have to hide that anymore. And I finally came up what was going to be on this shelf that has nothing to do with Star Wars at all, because this is a placeholder. You won't be here much longer. I'm sorry, but not really. So anyway, that tube that I jokingly said was a cold cathode display. I'm actually making another driver, and this one, because it's a 12-volt tube, I know, shocker, 250, 170, and flipping 12 volts over here that you could just run off your car's, like, 12-volt port. So anyway, it's going to have an actual transistor bank. I just have, like, this giant bucket of transistors. I'll show you just a second. Even if I connect a bunch of stuff backwards and half of these blow up, I have plenty to spare. Besides, I only need 16 transistors for that tube. Or just, like, stop being cheap and buy binary to decimal decoders and some shift registers. But I'm not doing that because I like transistors, and they're cheap. So anyway, no, I am not a cheap person. I like quality, but one of the things that I just cannot stand is when you buy, like, certain integrated circuits, and then that moment of realization when you're like, shoot, I just effed that up really bad, because you just connected it backwards and your ICs are making what us electronics engineers like to call the magic smoke. And I've had my fair share of that. It's not fun. When I was making this thing, I tried to use the 60-volt transistors on 170 because I was, like, being mega big brain, and all of them got stuck high, and the tube never turned off. It's just like one number after another was just getting stuck. So it was like 1, and then it would stick, and then 2, and then there was like 5 numbers in the tube on at once, and then all of them just started making smoke, and the tube got really unhappy. Luckily, I was testing it with an IN17. If I have one left. I remember using a lot of them and giving some to some of my friends. They're in here somewhere. I used to have those rectangle Nixies in here, but I don't anymore. Oh, there it is. In comparison, this is the world's smallest Nixie. That's the largest tube that you can buy. That's a pretty big difference. I mean, just look at the glass envelope on this thing. This itty bitty doinker is like... I will definitely be lighting this up for you and show you how small this thing really is. I mean, but this thing is like almost illegible because glow discharge, it doesn't matter how thin your wires are going to be. It's going to be 2 millimeter diameter no matter what you do. And with a tube this small, that is almost unreadable. It's just horrible. Now, I still think they're cute though because they were the first Nixie I ever lit up. But I'm just going to put them in their hard locker. I'm going to add more tubes to this stockpile. I'm trying to get my hands on a full-blown CRT. Some more VFD tubes. I got to restock on Nixies. And instead of some cat's eyes, I'm actually going to buy the tubes that classify as magic eyes, which are basically round cat's eye tubes. And I think they look nice. So anyway, if you're still here, thanks for watching till the end. And, thanks for watching. And see you next time.